The derivative of sine inverse is 1 over the square root of 1 minus x squared. So I'm going to go ahead and let y equal sine inverse. Recall that by definition of the inverse trig function, if y equals sine inverse x, then sine y is going to equal x. Now I'm going to differentiate both sides with respect to x. Okay, and the derivative of sine y, well, the derivative of sine is cosine, and then dy dx, yes, equals, and then on the right side, 1. Now solve for dy dx, we get that dy dx is going to be equal to 1 over cosine y. Okay, now to get the expression for cosine y, because we want our original function was a function of x. We want our derivative to be a function of x. Right now it's a function of y at this point. So what we do is we construct a triangle. Right triangle, and we think of sine, y is the angle, right? Sine of y, so y is the angle, so this is this angle here, y. And the sine of that angle is x over 1. And then just basic definition of the trig function, sine is going to be opposite over hypotenuse, right? I want to know what the cosine y, cosine of this angle, if I want to find the cosine of the angle, then I need to know what the adjacent side is. So just using Pythagorean's theorem, the adjacent side, I don't know what you want to call that, but sure. So that's going to be a squared plus b squared, right? Or a squared plus x squared, apologize. X squared plus x squared. A squared plus x squared equals 1. Subtracting over the x squared, taking the square root, we find that a is equal to the square root of 1 minus x squared. So therefore that side is the square root of 1 minus x squared. So therefore, what is the cosine then of that angle? So the cosine of y would equal adjacent, which is square root of 1 minus x squared over 1, right? So therefore, the cosine of y is the square root of 1 minus x squared. Then I can just come back to my problem, replace cosine y with that. So I get that dy dx is 1 over the square root of 1 minus x squared.